In this video, we're going to find exact values of composite functions involving inverse trigonometric functions from 6.2. Let's go ahead and get started. Inverse cosine of a negative value, that's going to return an angle in quadrant 2. Its cosine was negative √3/2, making that side 1. And the tangent of this angle is 1 over negative √3. So we'll rationalize that and make that a negative √3/3. Cosine is positive in quadrant 1. Cosine value of √3/2, making that side a 1. And the secant is going to be hypotenuse over adjacent, which will rationalize and make this 2√3/3. Let's draw this here and say arc tangent of 1, like that. And that side is going to be 2. Cosecant is going to be hypotenuse over opposite. It's going to be √2. Arctangent is positive in quadrant 1. √3/1. That makes this side 2. The sine value of the angle is going to be √3/2. Now we're going to need to slow down a little bit here because we have the inverse trig functions on the outside now. 11 pi over 6, that's almost 2 pi. So we're down here in quadrant 4. Reference angle negative pi over 6. And this is going to be a -1, a positive √3, and a 2. So this is the same thing as arc cosine of a -1/2. Well, inverse cosine for a negative value is going to have to return an angle in quadrant 2. So I need to draw it like this: -1, 2, √3. This reference angle here needs to be pi over 3. So this is going to be pi minus pi over 3 is going to be 2 pi over 3. All right. Again, we have the inverse trig function on the outside. So let's be careful. We have a negative angle for sine. So that's sine of -5 pi over 4, because of our even odd identities, is the same thing as negative sine of 5 pi over 4. So we have a negative, let's see, 5 pi over 4. 4 pi over 4 is here. 5 pi over 4 is here, and has a -1, -1, √2. So this is -1 over √2 is going to be 1 over √2, or √2/2. So arc cosine of √2/2, or arc cosine of 1 over √2. I like that just as well. We're going to be in quadrant 1, 1, √2, 1 here. This is pi over 4. Now we're back to having the inverse trig function on the inside, but this is not something that we're going to be able to find on our unit circle. We can't find 5 over 6. We just know that it's, just so you see the unit circle and see what's going on here, we're somewhere arc sine between 0, -1, and 0, 1. Here, our sine values are between -1 and 1, as our angles are between -π/2 and π/2. 5/6 is somewhere here between 0 and 1. This angle here, this theta, is arcsine of 5/6. So I'm in quadrant 1. So let me just go ahead and draw that triangle. Since I'm in quadrant 1, it has a sine value here of 5 and 6. Let's use the Pythagorean theorem to find the other side. So x squared plus 5 squared is equal to 6 squared. X squared plus 25 is equal to 36. X squared is equal to 11. And because I'm in quadrant 1, this needs to be positive root 11. So the tangent of my theta is equal to 5 over root 11, which I'm going to rationalize as 5 root 11 over 11. And that's it for this video. We'll come back next time and talk about 6.3. See you for the next video.